Good evening, everyone. So, how is everyone?
Fine, sir.
Uh, Done the questions?
No, sir. Uh, Objective type nonsense.
Okay, exercise questions done. Concept building one.
Yes, one. Yes, sir.
Okay. Do the exercise questions also. Okay, single choice question also. Okay, just let's wait for a minute. I think my knowledge is still there. Okay. Okay, let's just start. He will join then. Okay, let's go with the questions now. Okay, we have discussed about the uniformly accelerated motion, isn't it? And the meaning of uniformly accelerated motion means what? The acceleration of particle is what? Constant. Then only we can apply these type of equation of motion. Is that clear? Please tell me. We can only apply the equation of motion if acceleration is what? Constant. If it is variable, then these equations which we have written here, these four equations, that won't be applicable. Okay. So can we discuss some example on that? Right? Actually, let's discuss the example. All of you joined or yet Mrinal is not there? Okay, let's continue now. Okay. So in this example, what is given to us? A particle is moving uniformly. Okay. A particle is what? Having uniform motion. Okay. And starting from rest. Initial velocity is how much? Zero in the question. So now they are asking what will be the distance traveled in 0 to 1 second. Okay. Then what is the distance travel from 1 to 2 second? Okay. What will be distance travel from 2 to 3 second? Like that we have to calculate it. Okay. We have to calculate in the question distance traveled. Okay. Or better to say that ratio of distance traveled. Okay. Ratio of distance travel in 1 second interval. Okay, 1 second interval matlab after every 1 second how much the particle has moved, means first 1 second how much, then 1 to 2 second how much, then 2 to 3 second how much. That is what they are asking in the question. And when you will take that ratio you will find out that it is independent of the time interval. Even if I take a 2 second, 2 second, 2 second interval, I will still get the same result, right? So please tell me how much it will come, how you will solve it, tell me.
There isn't any acceleration.
Please tell, how do we, sorry? Yeah, acceleration is there. Acceleration is something constant given to us. It is always moving with what? Same constant acceleration. So tell me, I want the ratio, na? So ratio when we will calculate, it will get cancelled out. Okay. Please tell me how. See, let me calculate what is the distance traveled from 0 to 1 second. 0 to 1 second. How much it will be? Can I write it ut plus half a into t square? Is that clear? How much we got it? A by 2. Now I want to calculate distance traveled in 1 to 2 seconds. But if you are going to apply 1 to 2 second, then what will happen? Your initial point will become 1 second, isn't it? Please tell me, if you want to apply it 1 to 2 second, then your initial point will become 1 second. Na? So what is the velocity at 1 second? That will be your initial velocity. So that again we have to calculate it. Or isn't it, it will be better if I calculate it, what is the distance traveled from 0 to 2 second, and out of that 0 to 1 second I will subtract it. Please tell me. Understand this one?
Yes, sir.
Please tell. So 0 to 2 second, how much it will travel? 0 into 2. So half acceleration is 1, time is 2 second. Squared, what we are getting? Are we getting 4a by 2? So that means what is the displacement from 1 to 2 second? So will it become 4a by 2 minus a by 2? That is going to be 3a by 2. Next, tell me, I want to calculate 2 to 3 second. How much is that? Can you tell me what I am going to do it now? Instead of calculating 2 to 3, I will first calculate 0 to 3, isn't it?
Yes.
And from that, I will subtract 0 to 2, then I will get it 2 to 3. So 0 to 3 means what? U is 0, t half, acceleration is a, and t is what? 3 square. So we got it 9a by 2. So what will be displacement from 2 to 3 second? So 2 to 3 second means what? 0 to 3 second, we know that. How much is that? Out of that, 0 to 2 second,
Minus
I am
4a
going
by
to, yeah. So 2 to
ఎంతసేపు
3 second, yeah, tell me.
సరే
Can we, yeah, tell me.
సరే బాయ్
Okay, now you have joined it, Pranal. Okay. Actually, we have
ఎస్
just
సార్
started a question. Okay.
ఎస్ సార్ ఐ సా ఇట్
Right.
ఐ సా ఇట్
Okay. So 2 to 3 second, how much it will become? 9a by 2 minus
4a.
4a by 2. How much we got? 5a by 2. Do you see a pattern, or do I need to calculate further? Tell me.
You can
First,
see a
0 to 1 second, a by 2. 1 to 2 second, 3a by 2. 2 to 3 second, 5a by 2. Can you tell me what is going to come 3 to 4 second?
9a by 2. 7a by
7a by 2, right? So that's why that ratio is how much? Tell me. Is the ratio is 1 is to 5 is to 7, like that? Now, please keep in mind
is
one
to
thing
an
here,
is to.
that instead of tell me, instead of giving you 1 second as your interval, if I would have given any interval, but that should be equal interval. like 2 second, next 2 second, next 2 second, next 2 second, I will still get the displacement in the same ratio of 1:3:5:7. Please tell me, understood?
Yes, sir.
But only thing we have to make sure is what? The time interval should be what? Equal. Please tell, understand this question? So here what we did, here we have divided, we have divided the total journey into equal time interval. Then what will happen? Displacement of the particle is going to be in the odd ratio, 1:3:5:7. Same question, it will be asked in a different way. How? See, in this question, what I'm going to do it, I am going to divide this total journey into equal distance. Understood? Equal distance. So now what I will ask you, can you tell me what will be my question? Please tell me. Now my question will be, what is the ratio of time I am getting? Understood? First question, what I did, I kept the total journey into equal time interval. I got the ratio of displacement. Second time, what I'm doing, equal distance. Okay. Now I'm asking you the ratio of time interval, right? So please tell me, can we get this one? What you will do it? Will you first calculate what is the time taken to travel x distance? Right? Will I write it x equal to ut plus half at square? So is the time is coming 2x by a? Please tell me, under root. Is the time is coming 2x by a under root? Please tell. So this is the t1 for us, right? Now, if I want to calculate t2, should I calculate t2 or should I calculate this total journey? Please tell me. Here to here. Will it be better? And out of that, this t1 I will subtract and I will get the t2. Please tell. So what I'm going to do it, I'm going to first take the displacement 2x. 0t plus half a t squared. What is the t coming to us? 4x by a under root. So can you tell me what will be t2? Is it going to be under root of 4x by a minus 2x by a under root? Can you tell me third one what is going to come? This time I am going to take this total journey time, okay? T1 plus T2 plus T3 I am calculating. And out of that, the first 2x I will subtract it. I will get the T3 time. Please tell me, are you getting this one? What we are doing in the question?
Yes, sir.
So here, if I take it first 3 section as my displacement, then can I say the displacement now is going to be what? The 3x. Please tell. Now, are we going to have the displacement as 3x? Initial velocity is still 0t, half a t squared. So what is the time we are getting? 6x by a under root. So that means that t3 will become how much? Will it become under root of 6x by a minus 4x by a? Please tell me what is the ratio we got it as our answer. Is the ratio is coming? Just check it. Root x by a to common, na? Root x by a to common from everywhere. So that will not affect the ratio. So am I getting my ratio as root 2 is 2? Root 2 है ना, is to root 4 minus root 2 is to root 6 minus root 4 is to, can you tell me next one is going to be what? Root 8 minus root 6 is to, like that. That kind of order will be maintained. Please tell me, understand this one?
Yes, sir.
So these two questions are what? Both questions are based on the equation of motion only, But what is the difference in these two questions? In the first question, what we did? In the first question, what we did? Here, first question, we had the time interval equal, we got the ratio of distance. Second case, distance was equal interval, we got the ratio of time. Please tell, is that clear? And from here you can take it root 2 also common if you want, isn't it? You can take it root 2 also common, na? Check it, root 2 will be also common from everywhere. That ratio can become what? Root 1 is 2. Root 2 minus root 1 is 2. Root 3 minus root 2 is 2. Root 4 minus root 3, like that. Okay? Please tell, understood these two questions?
Yes,
Yes,
sir.
sir.
Please tell me, got these two questions? Now, let's discuss the next example. In this example, what is given to us? A particle is starting the journey with what? 5 meter per second. Okay. And it reaches a distance with 10 meter per second. Okay. This total distance is what? Or let's say that is not given in the question. Now they are asking in the question, find the velocity at the midpoint of the journey. Understood? This total journey is from A to B. So they are asking in the question, find velocity at the midpoint of the journey. Okay? At the midpoint of the journey. Please tell me, understood the question? Starting velocity is 5 meter per second. And when it finishes its journey, its velocity is given 10 meter per second. And the question they are asking, what is the velocity at the mid of the journey? Please tell me, how do we solve it? How should we solve this one? And it is always moving with what? Uniform acceleration. It is always having what acceleration? Uniform acceleration. Please tell, is that clear? The acceleration is always what? The uniform in the question given to us. So now they are asking what is the velocity at the midpoint of the journey. Okay. Please tell me. How should we solve this one? See, here in the question, can I say that, let me assume that this journey is what? What distance? Something x distance, right? So can I write it here? Final velocity, can I use this equation? V square minus u square equal to 2as. Please tell me, what is my final velocity? Is the final velocity is plus 10? Please tell me, because now I am going to discuss the motion under gravity, where plus and minus will be important thing to consider. Okay, now here all the vectors, velocity, initial velocity, final velocity, displacement, everything is in the same direction. So here we are not putting any plus or minus thing, and still we are getting our answer. But later, when the question will come where velocity is in one direction, acceleration is in opposite direction, so in those cases, plus and minus sign will be important. Okay. So here, what I have done, I have considered towards right as positive. The final velocity plus 10 square, initial velocity plus 5 square equal to 2. There is some acceleration and there is some displacement. Is this okay? Please tell me, is this equation clear to you? A question got asked. Question asks, tell me what is the velocity at the midpoint. So here the velocity is not known. So let me assume that velocity. Okay. I assume that that velocity is something v. So can I again apply the equation of motion between A and C? Please tell me. Can we again apply? Because acceleration is not known to me, na? But if I apply the equation between A and C and write the equation, you will see that it is not needed. It will get cancelled out in the calculation purpose. So between A and C, if I apply it, is the final velocity is v. Initial velocity is 5. 2. Acceleration is a, and displacement is x by 2. Look at these two equations. What are you going to do with these two equations? Please tell me, what are you going to do with these two equations? Can you divide these two equations? Please check. If we divide these two equations, what will happen? 100 minus 25. 100 minus 25. Right? That is 75 divided by v square minus 25. See that a and x is getting cancelled out? 2ax is getting cancelled out. So do I have 1 divided by 1 by 2? Please check it. 1 divided by 1 by 2. Please check it. All of you, please tell me, are you
Yes.
getting this one? So 75 equal to 2v square minus 50. That gives us the velocity at midpoint. How much it is coming? 125 by 2 square root, and unit what it will come? It will come as unit as meter per second. So please tell, understood this one?
Yes, sir.
Now I'm going to take an example where I will take the case of what? The retardation. How? See, sometime they will give a question like this. A bullet starts entering a wooden block with some velocity. Let's say it is given how much? 25 meter per second. Question gave what? A bullet starts entering a wooden block with what velocity? 25 meter per second. And the question gave what? That when this bullet moved by 10 centimeter, its velocity has become 25 to 10 meter per second. Understood? Please tell me. After moving how much distance?
Yes,
After
sir.
moving
10 cent.
10 centimeter, the velocity had changed. Yeah, the velocity had changed from 25 to 10. So now they are asking in the question how far it will move further. It will move now some further distance, isn't it? It will move some further distance and finally it will come to rest. The question is asking that thing. What is asked in the question? Question gave that a bullet enters with 25 meter per second and its velocity got reduced to 10 meter per second when it traveled 10 centimeter. So how much further it should travel to finally come to rest? And in the question gave, consider retardation. Isn't it the retardation or it is the resistance produced by the wood which is causing it to stop? Tell me. Is it the resistance or retardation of the wood which is causing it to stop? So question gave what? Consider the retardation as the uniform. Consider the retardation as what? Uniform. Then only now we will be able to apply the equation of motion. So how much further it will move in the question in this wood? So finally come to rest. Understand the question? So they are asking in the question, find the further distance. Try this one. Find the further distance bullet will move before coming to a stop. Before coming to
Sir, 1 by
stop. Understood?
52.5.
So please, how much?
1 by 52.5.
1 by 52 centimeter or meter.
Sir, in meters, sir.
1 by 52 meter coming means
1 by 5
around how much?
means 10 by 525 meters.
Okay. So let's see what we should do it. So here, is it the retardation case? Please tell me. Why retardation case? Because this wood will be applying the force in the opposite direction, will be causing it to retard it, slowing down, isn't it? So please tell me, what should I do it? Should I first apply the equation between A and B, and then it is finally coming to rest here? So again, I will apply the equation between B and C. But first, I should apply between A and B. So tell me, should I write it final velocity plus 10 square minus initial velocity plus 25 square equal to 2? What is the acceleration? Should I write it plus or should I write it minus here? Please tell me carefully, because what we understand here, what we learn here, is going to be applied in what? Motion under gravity question. So please tell me, should I write it here plus acceleration or
Minus, sir.
minus? I should write it here
Minus.
minus. Why minus?
Because
Because
it's
it is in
retarded.
the opposite direction. Not because it is retardation, because it is in the opposite direction of velocity, isn't it?
So that is retardation.
Retardation, it can be also retardation. See that?
Okay, so saying it's according to direction.
Yes, as per the direction of vector, we are
We are
writing it as the
considering that
negative.
side it's positive.
Yes, we are considering towards right as positive. So that's why velocity vector is what? Written as positive. Displacement vector is written as positive. But the acceleration is towards left, right? So that should be written as what? Negative. How much is the displacement? 10 centimeter or 0.1 meter, I can write it. Now, between B and C, if I apply it, final velocity 0, initial velocity plus 10 square equal to 2 into retardation will remain same. And how much is moved? We have to calculate it. I think we should divide this equation again. Please tell me, these two equations we should again divide it, so that what will happen? A will get cancelled out, 2 will get cancelled out, and we will have our answer. So what we have, 100 minus 625, right? 100 minus 625, that is minus 525 divided by minus 100 equal to 0.1 by x, right? I hope this is clear. So what is x we are getting? 100 into 0.1 is 10 divided by 525, and answer will come in meter. If someone wants to know the answer in terms of centimeter, then what we should do?
40
Just
by
multiply it by
21.
100. That,
Yes, sir. Multiply by.
crystal clear. So please keep in mind, whenever we apply the equation, we must consider the direction. Okay. If all are in the positive direction only, no problem. But it may be possible that something is in the positive direction and some other thing is in the negative direction given to us. Okay. So 10 into 100 divided by 525, the answer will come in centimeter now. Let me take an interesting question, okay? Because in this question, what you will learn, question gave something like this. A particle is starting with 10 meter per second, right? Its velocity is in this direction. This is the situation at t equal to 0. But it has a retardation of how much? It has a retardation of 2 meter per second square. Why I am calling it a retardation? Because this acceleration is in the opposite direction of the velocity. That's why I'm calling it retardation. You have to find out in this question, find displacement. Okay, what are the things we have to find out in the question? we have to find in the question, find displacement from 0 to 6 second. Understood? That is the first part. Second part, we have it in the question. Distance from 0 to 6 second. Do you understand the difference between these two questions? And the third thing is, if you can answer displacement and distance correctly, then you can also tell me velocity 0 to 6 second. And if you can answer the distance, please tell me, why did I ask it here? Displacement also and distance also? You will be thinking that it is a
Because
straight
there is a
line
turning
motion.
point.
So why the? Yes, there is a turning point in the path, right? And whenever there is a turning point, then what happens? Displacement and distance are not equal in that
Different.
situation. Displacement, yes, it will be different. And how do we know that where is the turning point?
First, we have to find where the speed is getting 0, and then we have to calculate the total, how much it traveled back, and we have to add them.
Yes, yes, that's what exactly we have to follow it in the question. So we have to first identify what is the turning point and how do we calculate the turning point. The simple thing is what is just to find out where the velocity has become zero. Because if it is moving someone in the forward direction, then how can it turn back? Its velocity becomes zero, and then acceleration will do what? Again, pull it back, isn't it? So first of all, find out what is the turning point. Can you see it and tell me what is the turning point?
From V equal to U plus AT, we can solve it. We'll
Yes,
take V
we will
equal to
apply
0.
what? V equal to U plus A. And in that equation, we will put it V equal to U plus AT. We will apply it. I'm going to put V equal to 0. Initial velocity plus 10. Acceleration is minus 2, right? Towards right, I am writing as what? The positive one. Okay. Into t, that gives us t equal to 5 second. T equal to what? The 5 second is the turning point time, right? So particle from 0 to 5 second, it will move towards right. And after 5 second onward, it will turn back and it will keep on moving in the backward direction. Is that clear? So can I separate or can I bifurcate this total journey of 0 to 6 second in the two part?
Yes, sir. One from 0 to 5,
0
another from
to
5 to 6.
5 second is the forward journey and 5 second to 6 second is the backward journey. Please tell me,
Backward.
all of you are clear about this thing?
Yes, sir.
Please tell, I got only one answer.
Yes, sir.
Please tell me, clear everyone? So 0 here,
Yes, sir.
t equal to 5, particle here, and from 5 second onward, the particle is returning back. And this is somewhere the particle will be there at t equal to 6. I don't know, I have to calculate that one. Is that clear? Acha, tell me, in the same question, if I would have asked, what is the displacement from 0 to 4 second? And what is the distance from 0 to 4 seconds? Would I have
Both would
got
be
the
same.
answer?
Yes, sir.
Would I have got a different answer for displacement and distance?
No, sir. No. We'll get the same.
Right, because there is no turning back happening in 0 to 4 second ever. So 0 to 4 second, whether you calculate me the displacement or distance, I will get the same answer. Right? Actually, let's calculate it. Can I calculate it for 0 to 5 second? What is the displacement from 0 to 5 second? So U into T plus half, acceleration is minus 2, t is 5 squared. So it's a 50 minus 25. 25 meter we got it. And 5 to 6 second. So 5 to 6 second, what will happen? So 5 to 6 second, so here the
Initial velocity is
velocity is 0, na?
yes.
Velocity is 0. So now I will take initial velocity as 0. And further 1 second interval is there. 0 into 1 plus half. Acceleration is minus 2. And t is what? 1 squared. Am I getting minus 1 meter as my answer? Can you tell
That
me
is
what does
this.
it mean by plus 25? And what does it mean by minus 1?
So 1 meter in the opposite direction.
Yes. Plus 25 tells me that the particle is going in this direction. And minus 1 meter is telling me particle is coming back like this. So it plus and minus is representing what? Just the direction. So please tell me, what is the displacement? Can you answer now quickly all these things what I asked in the
26
question?
meters.
What is the
24 meters.
displacement? Check it. 25 forward,
Minus
1
1.
backward. So 24 meter will be there. What will be distance?
26 meters.
25 plus 1, 26 meter will be there. Now, once the displacement and distance is known, it's very easy to calculate the average velocity and speed, isn't it? Average
Yes, sir.
velocity will become total displacement by time taken. Average velocity will become total displacement by time taken, and average speed will become what? Average speed will become total distance by time taken. Please tell me, clear this one?
Yes.
So this is what happens if the particle is returning back. Whenever there is a chance of particle to turn back, always locate the point where onward the particle is returning back. Okay? And if your question asked time interval is beyond the returning time, है ना? Then you have to calculate displacement and distance separately. So please tell, is these things are clear? The accelerated motion, or better to say that uniformly accelerated motion. So let's move to the next part now.
Instantaneous.
Okay. Okay. So next we are going to discuss instantaneous velocity, instantaneous acceleration. So we can directly calculate it using what? Uh, the differentiation method. Okay, na? So we'll come back to that one. Before that, let's discuss about the motion under gravity. Although we are going to write it like a new topic, but it's not a new topic. Why it is not a new topic?
The
Because
acceleration value we know. Just
yes,
follows.
yes. See, whatever question we have solved it in the horizontal direction, sometime v is given, time given, acceleration they are asking in the question. Sometime other variables are given, right? Acceleration is also given. We are calculating the displacement, distance, these things. What happens in motion under gravity? Tell me. What is the one important factor in motion under gravity? The one important thing in the motion under gravity is what? The acceleration is always known to us, isn't it? If a particle is doing motion under the influence of gravity, that means, can I say one thing, which is the acceleration of particles is always equal to what? Acceleration due to gravity?
Yes, sir.
So that is the one of the less variable. That means what? If a particle motion is happening under the influence of gravity, then we always know the acceleration. And how much is the acceleration of the particle? So in this kind of motion, acceleration is, how much is the acceleration? Acceleration is
9.8 or 10.
always, yes, acceleration is always equal to g. How much is the g? 9.8 meter per second square equal to g. And which direction it is?
Always downwards.
Always downward direction, because the value of acceleration due to gravity near the earth's surface is always constant in magnitude and direction. But if we go 100 kilometer above the earth's surface, will it still have the same g?
No, sir. It'll have a bit less.
Yes, it will keep on changing, isn't it? Because the acceleration due to gravity changes as we go more and more height above the surface of Earth. Okay, so acceleration is always equal to what? G in downward direction near the surface of Earth. And all these motions are happening what? Very close to the surface of Earth, isn't it? Near the surface of Earth. Okay. So that means one variable is always known, and it's what kind of acceleration, and it is also constant one. Okay. So now in motion under gravity, what happens? Few things they will ask you in the question is like, what is the time of flight? Right? Time of flight means total time taken by the particle to stay in the air, isn't it? Means if you throw a particle up, it will go to some height and again it will come back, na? So how much time it has stayed in the air, that is called the time of flight, right? So let's discuss that one. Some standard results are there. Let's first discuss that one and then we will go to the question part. Let's say I am sending a particle with u velocity. So how it will go? It will go up, it will reach a certain point, and again it will come back to the same point now where it is projected.
Yes.
Although I have shown it by two different lines, but just for understanding, okay? Please tell me, is the particle is going to follow the same path in the upward journey and same path in what? The downward journey. Can you tell
Yes.
me with what velocity it will come back? Will it come back with the same u? If we don't consider any air
Air resistance.
resistance, right? If air resistance is there or air drag is there, then it won't come back with the same velocity. Its velocity will be different. We will take one example based on that also. That what happens if air drag is considered in the question. Okay. Now tell me, what is this point called as? Is that distance is called as the maximum height? And why do we call the maximum height? Tell me, why do we call this height to be the maximum height? Because particle didn't go beyond that. And why particle didn't go beyond that? Because at the time of reaching that point, the particle velocity has become zero. So
Zero.
that's why at the maximum height, particle vertical velocity will be what? Zero. Clear? And it's just one direction motion. The vertical velocity zero means overall velocity is what? Zero. Okay. Now let's calculate few things. What is the maximum height? So to calculate the maximum height, can I use it? V square minus u square equal to 2as. Right? For maximum height, what is going to be the equation I am using? The final velocity, 0 square, initial velocity plus u square equal to 2 is equal to 2. And what is the acceleration? Please tell me what I should write acceleration here. Should I write it minus g?
Minus G.
Right. Why? Because I am writing upward direction as positive. Velocity is initial velocity. So upward direction is positive. So the downward vector will become negative. And g is which vector? Downward vector, isn't it? And this displacement, let me call it as the H max. So what is the H max coming to us? That is coming U square into G. What is the time taken to reach the maximum height? Can I use it? V equal to U plus AT then? So at maximum height, velocity is 0, initial velocity plus U, acceleration is minus G, and this time I calculate this T I am getting as U by Z. You know what is this time called as? Time of
Time of flight.
ascent. How much time it took to?
Time of
No, no, this is time of ascent only, no?
total is time.
Yes. This is only time of ascent. What will be time of flight? Time of flight means
2U by
total
G.
time taken. Total taken means what? Time taken to go up and again come back. So for that time is called as what? Time of flight. So for time of flight, can I say that total displacement is zero? Can you tell me total displacement is zero or not?
Yes, sir.
Because
Sounds
it
like
has started from whatever point, it again come back to the same point. So total displacement zero. Initial velocity plus u into t plus half. Acceleration is minus c into t square. So this t is coming as what? 2u by c. This t is called time of flight. And please check it. Is the time of ascent is equal to time of descent?
yes, sir.
Please tell me. Time of ascent is equal to time of descent. And
Descent.
time of flight is what?
Time
And
of
are
ascent plus
they
time of
right? And can we also write it? This is going to be half of the time of flight. So these are few of the concept, you can say that, few of the formula, you can say that. Now based on those formula, we are going to have some question and also the application part, not directly based on the formula question, but with the application of those concept. Now we are going to do it. Okay. So let's discuss some question. Do you understand up to this? Please tell me, clear up to this?
Yes, sir.
Now, let's start with an example. This is the formula for ground to ground. Ground to ground means what? Whatever height we have projected, it again come back to the same height. But that won't be the always the case. Sometimes we will project from some height, some tower height, and then it will go some height and then fall back to where? Fall back finally to the ground. Means projected from some height and reaching the ground. That kind of situation is also there in the question. Okay. Clear?
Yes, sir.
Okay. So let's say in this question, what is given to us? A particle is started with 20 meter per second. Okay. So it will reach now some maximum height and then again it will come back. So you have to find out two things here. First, tell me what is the maximum height? What is the maximum height in the question? Take G as 10. For simple calculation, take G as what? Approximately 10. It's 9.8, hai na? So if you put
20,
it in
sir.
the fraction, you will get it little bit complicated result. So better to take the G as what? Approximately 10. The calculation will be very much more
20.
simpler. 20 we are getting. So now the question asked two part in the question. First part, find maximum height. I can again ask you another formula based question that find the time of flight. of flight or find the time of ascent like that. But you know that you can get it directly putting in the formula. Find maximum height. And the second thing, time, okay, time when the particle is at half of the maximum height. Half of maximum height. Now to solve this question, I need a maximum height. What is that? Then only now I will be able to find out what is the time taken to reach half of the maximum height.
Yes.
So please tell me what I should do it now. First of all, I should calculate the maximum height, isn't it? The maximum height calculation is very simple, isn't it? Can I write it? H max equal to u square by 2z. U is how much? 20 square. 2. G I am taking approximately 10. Okay. So 2 into 10, so we got it as what? 20 meter. So it means indirectly what I am asking you, tell me when it reaches 10 meter above the ground, isn't it? Achha, now tell me, how many times particle will be at 10 meter from the ground?
2 times.
Once or twice?
Twice.
2 times. When? One at the upward journey, right? When at the time of ascent, and the second at the time of descent. It will be at the same height. Na? So here, second part, is there going to be two answer of the second part of the question?
Yes, sir.
Right? So let's calculate those two time. Okay. So how do we calculate it? So to solve the second part of this question, can I say, is it the point where my particle is located? And initially the particle is here. So in both the points, what will happen? Can I write the displacement is going to be, I'm going to use this equation. Okay. S equal to, I'm going to use it. S equal to ut plus half at square. Okay. So please tell, what is my displacement? Is my displacement is plus 10? Is my initial velocity is plus 20? Time I have to calculate it. Half acceleration is minus 10 into t square. Please check it. Has it become a quadratic? Has it become a quadratic? 10 equal to
Yes, sir.
20t minus 5t square. You can cancel the t. If you, sorry, you can cancel the 5. So it become 2 equal to 4t minus t square. So this is a quadratic. T square minus 4t plus 2 equal to 0. Please tell me.
We'll get 2 plus or minus root 2.
Yes. So now this is a quadratic. So we are going to get what? Two solution of this quadratic equation, isn't it?
Yes.
So what are these two solutions are going to tell us? So one solution will tell me at what time I will be at this height at the time of going up. And the second solution will tell I'm at the same height, but this time I'm coming back after reaching the maximum height, isn't it? So what is going to be the solution of this quadratic? Is it going to be minus of minus 4 plus minus b square, that is 16 minus 4 into a into 2 divided by 2 into a. So we have 4 plus minus 12, right? 12 means 2 root 3.
By 2.
Wait. It's
2
8,
root
na?
2, sir.
2 root 2
2
divided
root
by 2. So we have our answer as 2
plus or
minus
minus
root 2 and 2 plus root 2. Can you tell me what are these two times? Which
2
time is
minus root 2 is
at the
time of
time of
ascension.
going up? And which is, yes, 2 minus root 2 is the time when I reach that particular height which was asked in the question at the time of going up. And 2 plus root 2 That is the same height I reached
Going
at
down.
this particular time also, but that time is what? When I am coming back after reaching the maximum height. And how do we decide that? By looking at the value, isn't it? At the time of going up, I will reach first, na, at that height.
Yes, sir.
So this will be what? Time at the time of, or
Initially reached finally.
time, sorry, time in the ascent. है ना? You can say that time in the ascent journey.
Yes,
This is
sir.
the time at the time of ascent.
Sir, we can't see your presentation.
Screen not visible.
Sir, now is
Yeah. Actually, that got clicked on the. Okay. And the second one will be what? Time So please tell me, understood these things or not? Right? We have to
sir.
discuss some questions when we are going to take the projectile from some height. Okay? So please tell me, are you okay with the pace, what we are
Yes, sir.
discussing? And yeah, please tell me. Now you have taken the class around, uh, it's been around 3, 4, 5 class we have taken, right? So my process will be what? Discussing each and every topic and the examples related to those topics. And after that, you have to practice all types of question from the single and HCV. Okay. And after that, once it will finish the chapter, I will give you some, you can say that assignment or the handout. Okay. So that you can practice some extra questions from those topics. So please tell me, is it going fine?
Yes, sir.
Yes, sir.
Please tell me, all of you.
Yes, sir.
Yes, sir.
Right. So let's meet it tomorrow. Now I will send you some more question. I think we can discuss it now. Let me check the book. Okay. And tomorrow again we will continue from the electrostatics part. There
Okay,
also
sir.
we have discussed about the field lines, right? So let's meet it tomorrow. Okay. Take care, everyone. Bye bye.
Bye, sir.
Thank you, sir.